Good afternoon, everyone, or good morning, depending on what part of the country or world that you're listening in from. Welcome to part 7 of the Hospital Hardware Applications ASA ABLOY Virtual Instructor-Led Training. My name is Katie Flower. I will be your lead instructor. Just want to remind you this session is being recorded. In case you've missed any, they are on the ASA ABLOY Academy website. Click on the virtual instructor-led training, and on the top right is a listing of the recordings. You can review as often as you need to, or if you happen to miss part or all of a session, to stay on track. Tomorrow's session is going to be a lot of fun. We will review any other types of openings that we haven't been able to focus on throughout the series. And there will be some interaction. I'll have some polling questions, put a piece of hardware up on the screen for you to identify, ask you maybe a code question, something like that that's been related to hospitals that we've talked about throughout the last 2 weeks. Within 24 hours of today's session, you will receive an email from us thanking you for your attendance. You can use that email as proof for continuing education credit for 1 credit hour. It is self-reporting. And if you have any questions, the way that we've been doing it is go ahead and ask your question using the Q&A button. I'll take a look at the question real quick as I'm talking about an opening. I may wait until the end of the conversation about the particular opening before I answer the question, but I will say the question out loud and answer it for you. If it's pertinent to exactly what I'm talking about, I'll try to answer it right then and there. So feel free to ask questions as frequently as you have them. Today, the first opening is a staff lounge. This is down in the basement. You will have staff lounges scattered throughout a hospital. Some will be on stage where they may need card access. This one does indicate card access. The wall is fire rated. You can look at the legend to see that the 1/ is a 1-hour wall. The door is 45-minute rated. Most architects do not put the fire rating here with the door number. This particular architect does, which makes it very easy for you. But you would find this information from the life safety plan or the door schedule to indicate that it is fire rated. A shift change staff lounge area is, doctors, nurses, staff will come in here. They'll use the microwave. They'll have lunch or whatever, maybe even sit and watch a little bit of TV in between while they're taking a break, and then they'll go back to work. So it's quite busy. It's not super high frequency. We can see that this door swings up against the wall. We don't have any limitations to that. So you should be thinking already, okay, I've got card access. I've got a door that swings against the wall. It's a standard 3-foot wide door. It's fire rated, so it's gonna need a door closer. You would put a door closer on this anyway because of the card reader. Typically, if you have card access for security purposes, that goes hand in hand with the door being closed and secure. And therefore, a door closer is normally what should come to mind, whether this is fire rated or not. The other thing I want to point out, think to yourself for a second, does this lock that goes on this door that works with this card reader, does it need to be fail safe or fail secure? Think about it for just a second. As long as you have free egress from this staff lounge to get out, which the inside handle of either a fail-safe or fail-secure mortise lock would allow you to do. Either way, I can exit this space. Do I need to get back into this space if there is a fire? If there is a fire, I'm going to go down the hall and around the corner to the stair and get out of the building using the stair. There's no need for me to go back into this room unless, during the fire at all, ever. Once the fire is either out or it was a false alarm or whatever, authorized people can get back into this space. This can be fail secure. Any room that you can normally lock with a key, classrooms, storage rooms, offices, any type of room that you can normally lock with a mechanical function lock set can be fail secure if you need to make it access control. So this is just a Mortise lock that has wires in it. Fail secure means that when the power is out, I need a key to get into this space. I can always get out. I have free egress. Because this is a Mortise lock that allows free egress, this can be fail secure. Let's take a look at the hardware set. It is a 3-foot by 7-foot wood door by hollow metal frame, 45-minute rated. Let's take a look at the video. Pretty simple. Hang the door. It's a moderate frequency door. It's not wide. It's not heavy. So standard weight hinges, anti-friction bearing steel base metal for fire rated doors, satin chrome finish. The McKinney TA 2714 meets all of those requirements. The A is an oilite bearing instead of a ball bearing. Either one is acceptable by NFPA 80, the standard for fire doors. And the through wire hinge will go at the center location. A top hinge usually takes the most amount of the brunt of the force when the door opens and closes. Gravity wants to pull on the screws on that top hinge. So we don't want to put the through wire hinge up in this location. We put it in the center for 2 reasons. Number 1, it's not a load bearing hinge. And number 2, it's closer as a direct shot. Your electric raceway that will be drilled at the factory has a direct shot from the hinge to the electrified lock. When you're writing the specification, you don't need to identify the number of wires. When you're estimating this, you can figure it as a 12-wire hinge. It doesn't cost that much more than a 4-wire or 6-wire hinge. When you're detailing it, you would have to figure out how many wires are needed for the function of the lock and any monitoring that there is for that door. The lock set is fail secure, which means that the latch bolt is retracted by the key from the outside if you use a key, or if you have a valid credential, you can hold it in front of the card reader. It will unlock the door momentarily to allow you to get into the space. When the door closes, it relocks. Free egress from the inside at all times. That's our proof to the AHJ, the authority having jurisdiction, that we don't need to meet any additional codes. And we have the same lever and rose design that we had on the rest of the project. And the rest of the part string, the M92 is request to exit. The request to exit switch is on the inside handle. When you turn that handle, the switch is telling the security system, this is a valid exit. Somebody's not breaking into this room or space. They're not coming in from the outside because the card reader hasn't been activated. The request to exit switch shunts the alarm so that the alarm system won't happen at that time. And the CT7 SD is the temporary disposable construction core. For interchangeable core, the permanent core is listed as a separate line item that will be ordered after the final keying schedule has been approved. Control the door, an architectural grade closer works very well here. We do need to have a closer. It is a fire rated opening, and in the specification, you can be generic and say regular/parallel arm as required. This would be the same price. In fact, the 8501 from Norton comes with both a regular arm and a parallel arm bracket. You do need to detail this if you're writing the submittal so that the contractor mounts the door closer on the proper side. The DHI teaches, the Door Hardware Institute teaches that the rule of thumb, we keep door closers on the inside of rooms, inside of stairs, and not in the corridor itself to every extent possible. There are some exceptions. We'll talk about those exceptions tomorrow. But for the most part, we try to keep the closer on the inside of the room, on the inside of the building, inside of stairs. Protection plate, every time that we have a door closer, if you've got your arms full and you're going into a door that has a door closer and it starts, you can feel the back check pushing back at you, your tendency is to push the bottom of the door with your foot. So the kick plate protects the bottom of the door, and we have 10-inch by 2-inch less door width. That's the way it would be specified. If this were being detailed, you would put the actual 10-inch by 34 inches and then the other suffixes. The B4E is for beveled four edges, and the CSK countersunk holes so that your screws don't stick off the face of the kick plate. Smoke seal is not required on a 45-minute rated door, but I have mentioned several times that, especially in hospitals, smoke gasketing is so inexpensive. It's a best practice to use on all fire doors, even if it's not required. It is very low profile, compression, silicone, self-adhesive backing, and easy to install. It cuts down on not only smoke, but odor and sound. And it's just a very inexpensive insurance policy. Miscellaneous items always go towards the end of the hardware set. The Electrolinks harness would be sized for the door, the number of wires and width based on the size of the door. So a QC C400 if this were a 4-foot wide door, QC C300 for a 3-foot door, which is what this is. And then it's for between the hinge and the lock set or exit device trim. The symbol, the little flash symbol, anything with the flash symbol, if Assa Abloy wrote the specification, this indicates that it's an electrified hardware item, and it's still provided in this section, but it kind of helps flag the GC and the architect to know this is an electrified item. The Mortar Guard, this frame is in a masonry wall, so the frame will be grouted in, and this helps protect in that middle hinge location where you've got your Electrolinks harness. It makes sure that it doesn't fill the whole frame with grout. You have a space to tuck your wires in. And it's easier to put this in the specification set, and whoever is detailing the project, if you've got a combination, some doors in this set are in masonry walls and some are in drywall, sheetrock walls, you don't need to include this for those that are in sheetrock. You can just omit this. But every place where you've got a masonry condition, you want to use the Mortar Guard. The operations narrative is always critical for any set that has electrified hardware because it describes the functionality. What happens from the outside, what happens from the inside of the opening, what happens on loss of power, and do you have to tie into the fire alarm system or not. Here it says the door is normally closed, latched, and secured. Valid credential at card reader unlocks door momentarily for entry. Free egress at all times. Key override outside in case of power outage for entry. This is a short, succinct operations description that should be in the specification, but it also needs to be in the hardware submittal for approval. So the owner can see this and say, yes, this is a door that's normally closed, latched, and secured. Yes, this is intended, this is exactly as I intended that opening, and that's the flow and functionality of what I want. The architect has protection also by having this narrative approved by the owner. The electrician can wire it. There is no question which wires go where, and the monitoring for the request to exit for the security panel. Here is the hardware set one more time, and I'm going to open it up if you have any questions. The question is, can I discuss electric strike versus electric lock on this opening? Was it an owner decision? In a brand new facility, especially a hospital, electric strikes are more for traffic control than they are access control. If this were a retrofit, then an electric strike could be a very viable option. The reason that we don't like to use electric strikes on new construction in hospitals, especially high traffic areas or moderate traffic areas, when you have a mortise lock, the center line of the latch bolt is not the same as the center line of the strike. And if you're writing a specification and you have 3 manufacturers for mortise locks, let's say Corbin, Russwin, Sargent, and Schlage, and then for the electric strikes, you have 3 manufacturers listed, HES, Von Duprin, and Fuldratum, whatever the 3 manufacturers are. If the detailer, the supplier, the actual hardware supplier that wins the job does not coordinate properly between the electric strike and the lock set, and the frames get installed and that electric strike is not at the correct height, that's going to create a major problem for the facility for security reasons, as well as somebody's got to fix it, and then you don't quite get exactly what was wanted in the first place. I've had hospitals before where new construction, there were electric strikes, the supplier didn't notice the templating, ordered the frames with the electric strike in one location, then they had to try to modify with face plates. It's just an extra layer that you don't really need. You're gonna have a mortise lock anyway. You're gonna hang the door anyway. It's brand new construction. Why not do the through wire? It doesn't cost any more for new construction to put a through wire through the door. If you've already got the mortise lock, go with the electrified mortise lock over the electric strike. Now, if this were a door that for traffic control, we just wanted to buzz somebody in and use, the reception area, you're just pushing a button to let somebody in, then that's more where an electric strike would be used. But for the day-to-day high use doors, you're not going to go wrong if you have the mortise lock and use the standard ASA strike that comes with it. Very good question. It's always a debate one way or the other. And sometimes you will find a facility the owner will want. But if I'm the consultant and I'm making a recommendation, I'm going to recommend they use an electrified mortise lock rather than an electric strike, or if this were an exit device, electrified trim on the exit device instead of an electric strike in new construction. Retrofit is a different story. The other thing is, if this were a single door with a power operator, then yes, I would use an electric strike, because the electric strike allows the latch bolt to push past the keeper and the door can open without having to have any kind of latch retraction. So there are cases made in both directions. From my experience, that's what I have seen. Any other questions on this opening? Okay. The next is a pair of doors in a receiving area, and we'll take a look at the floor plans first. This is also in the basement. It's just around the corner from that staff lounge, and that stair door that we did on day one is down over here. The electrical room that we did is over here. But this is a pair of doors going into this receiving. What I'm looking for on this opening, I see that it has card access, so I know that I'm going to need some kind of electrified hardware. I see the PP for the push plate. That indicates to me that there's a power operator to open these doors. And I know that when I have a pair of doors with an auto operator in a hospital, that's going to be surface vertical rod or concealed vertical rod exit devices, less bottom rod, electric latch retraction. And these doors do swing against the wall, so I'm thinking wall stop. I do see that it's a 1-hour wall, just like the one around the corner, and it is a 45-minute rated door, fire rated opening. It's going to get a lot of use in and out, so high frequency. I'm probably going to hang this door a little bit differently. Here is a little bit closer look, so you can see the push plate and the card access. In fact, this push plate was a wave switch to keep it even cleaner than having to push on the door. No, I'm sorry, they did use push plates on this one. I'm thinking of a different hospital. So this is an actual push plate, but there are a couple different options. We'll talk about that when we get to the hardware set. The pair of doors is 6 foot wide, but even though it's 6 foot wide, when you have a power operator and high traffic area, a continuous hinge is a more stable way to hang the door. We'll talk about that after we watch the video. And the hardware set continues so that you can see the rest of the set, including the operations narrative. And we have a question. Okay, we had a pair yesterday that didn't require exit devices because of I2 classification. Why is this pair different? Is it an assembly classification? This is not assembly. We'll go back to the plan for just a second. This is just a receiving area. In fact, this is a morgue, so there's not a lot of people that will be in here. The reason that we use the electric latch retraction exit devices here, the other was added more towards the last minute, and this one was in the project to start with. And keeping the Corbin Russwin, yes, we did have the electric latch retraction, the solenoid driven, so I'll tell you the differences when we get to the hardware set. But exit devices are not required by code, but for the functionality of the power operator with the electric latch retraction, that's why we use this here. The other one was, this project took 4 years to design and build. By the time that it was built, some of the changes, by the time that the change was made, new technology had come out or different things had changed, and so that's why they were different. Theoretically, yes, this could have been that same Sargent 7000 device. Oh, I know the reason. Oops, sorry. The other reason is this is a wood door. The other one was a metal door. And I wouldn't put concealed vertical rod in a wood door that gets any kind of high use. And this is a fire rated wood door. So it would have the metal channels, the 5-inch wraparound metal channels on the meeting styles. It would look awful. It wouldn't be, the door itself wouldn't be as heavy duty as the hardware, and there would be problems. We don't want to have any problems in a hospital. So the other door being metal, the 7000 device made more sense. This one being a wood door, it makes more sense to have it surface vertical rod, less bottom rod. Good question, good catch. But you notice that we do have a controller. We'll talk about that when we get to the actual breakdown of the hardware set and the differences. Here is the hardware set. Okay, so hang the door, high frequency, high abuse area, power operator, wood door, fire rated, and this is where we would use the Marcar pin and barrel stainless steel hinge as compared to the aluminum geared hinge, which I use on the hollow metal doors. This does have the CTP prep, so the CTP is a power transfer. Instead of having through wire through the hinge itself, this allows the wires to be a little bit thicker. This allows the wires to be a little bit thicker, which for the inrush of power that you need for this exit device to retract the latches in a high frequency opening, this is more recommended because of the use and the inrush. The MB is the medical bearing for the Mortar hinge. It's an actual nylon insert. And I don't know if you've ever seen on a continuous hinge, after time, you'll see at the knuckle joints or at the gear joints, also on an aluminum hinge, you'll see black. That's from the particles that are in the air. And in hospitals, they change the air every hour, like 6 to 8 times per hour. And that puts a lot of circulation of air down these corridors. And that means you've got dust, what dust and particles that do exist, you have those in the air. The medical bearing captures that so that you're not going to see black on these hinges. The medical bearing captures that and keeps it in the hinge. One of the questions is, would you go to the architect and recommend a hollow metal door versus a wood door? In certain cases, yes, I would, absolutely. If they want, if for example, they said, we want concealed vertical rods, then I would highly recommend to the architect that they change those doors to hollow metal. If it's a hollow metal door that needs to look like wood, Curry's and Seco make the Madeira doors with the wood grain. So you can make a metal door look like a wood door if they need the look of wood, but the durability of hollow metal. The nice thing too about the reason why I use the pin and barrel continuous hinge, you notice the wraparound, the way that it wraps around the edge here. And that protects the edge of the door as well as hangs the door. And so an aluminum continuous geared hinge doesn't wrap around the edge of the door quite the same. This protects the edge of the door a bit better. And there's 2 questions on any reason why the transfer prep is located higher than the exit device. I don't know. I would assume that whoever the supplier was looked at the templating and that's where they located it. That was nothing that I had anything to do with. So I couldn't tell you. I'd have to look at the templating to see why. But they did make sure to match up the door and the frame, which is a good thing. The exit devices are surface vertical rod, less bottom rod. They are fire rated devices, so there is no mechanical dogging. There's trim on just the one leaf. That's why these are 2 separate lines. That's the only difference really between these 2 lines. There's a lot of suffixes. We'll take a look at each one of those individually. We have the M55 less bottom rod. We want to make sure that there are no strikes going into the floor. The question is, would that qualify for positive pressure then? It has to, because it's a fire rated door. Without calling the manufacturer and looking into it specifically, but the manufacturer would not prep for that. They would have put a red flag up if that would have violated. That was not something that was done in the field. It was done at the factory. And if there was any question about it, it would have been handled at the factory. Another question, what is positive pressure? When it comes to fire doors in the United States, the International Building Code requires that all swinging fire doors are tested under positive pressure. It's the way that the fire test is administered. So after the first 5 minutes of the furnace getting to 1,000 degrees, the test furnace, rather than ventilate the smoke and hot flames and gases out of the top of the furnace like a chimney, it moves the pressure plane down to 40 inches above the sill and the doors have to have, wood doors have to have concealed intumescent, which expands to seal the gaps so that the cool air is being sucked in underneath the door, but the hot smoke and the hot gases cannot be forced out through the top of the door. Other prefixes, we have the same trim that we've been using, and they went with the classroom function here as well. Typically, when you have access control, you would want a storeroom or night latch function on your exit device, but this owner did say that there were times when they would want to have this unlocked and bypass the card reader system. Trim on just the one leaf. You can see the through bolts for all of the items, in fact. And then all of the other suffixes. The M91 is a bolt position monitor. That monitors the position of the latch bolt. And why that's incredibly important on an opening with a power operator, a power operator does have the ability to delay the opening cycle 2 seconds, 3 seconds, 5 seconds, whatever you set it for, to give the electric strike time to release or to give a latch retraction time to retract the latch. But what happens if after the 3 seconds, that latch hasn't retracted all the way yet? That puts the door in a bind. When that door tries to open, the power operator tries to open and the latch isn't fully retracted, that puts the latch in a bind. And then eventually, the longer that goes on, the more damage it can do to the door. The latch bolt monitor, whenever you have a power operator and electric latch retraction exit devices, I highly recommend that you use the bolt position monitor so that when the bolt position monitor is nothing more than a switch. So it can be just like a card reader or just like a push switch, the push button switch. That can be what signals the power operator to open. So the card reader on the outside and the press wall switch on the inside actually signal the latches to retract. When the latch is fully retracted, the bolt position monitor is what signals the power operator to open the door. You will never have the doors in a bind if you do it that way. And on high traffic openings, doors that have to be super reliable, especially here in a hospital, that's the way that you want to go. Very inexpensive to have that latch bolt monitor. The touch bar monitoring or signaling, the M92 is request to exit, which if they did push on the bar to exit the door, would just signal the access control system for the door not to go into alarm. The M94, this is Corbin Russwin's old way of having the electric latch retraction. Now it's the MELR, the motor electric latch retraction. And with the motor electric latch retraction, you don't have a large inrush of power. With the electric pullback, this M94, that's a solenoid operated, and you did have the need for a separate power controller. We'll get to the power controller in just a minute. The M110 is the heavy duty end cap, and that again helps protect the exit device from carts and stretchers and anything hitting the end of the exit device. It gives that exit device more durability. There's a question, so opening the device manually does not trigger the bolt position monitor. No, it doesn't, and it doesn't trigger the power operator. Opening the door manually from the inside or using the key from the outside is completely fine. The power operator was supplied by the different section. You can see the section listed here. It does indicate that it's electric. They do use the extra safety sensors, even though they're not required on low energy operators. There is one door switch for the inside. The card reader is what opens from the outside. Protecting the door, armor plates protect the whole bottom of the door. And when you've got the wraparound edge guard, if you're detailing this, then it may not actually be 2-inch LDW. For a pair of doors, it's typically 1 inch less door width. and you would coordinate that with the width of the thickness of that edge, the wraparound edge on the continuous hinge. It does need to be fire rated because it is on a 45-minute rated door. Heavy duty cast wall stops so that they don't get banged up. Sealing the door, they did, because this is the morgue area, they did want to have extra sealing. So we had the astragal brush, astragal, and the brush door bottoms. The ELCEPT power transfer allows for 22 gauge wires, which are thicker than what you would have if you just went with the prep for the one that's in the hinge. And they will prep for the CEPT at the factory. The controller. This was when Corbin Russwin was selling solenoid operated electric latch retraction. You needed the special power controller. There is a large inrush of amperage. In fact, a 9 amp inrush for 100 milliseconds. It's high voltage coming into the power supply. It's got a transformer inside and rectifier to get it to the low voltage. It will pull back the latch, and then it could hold it in the retracted position and drop down the power. It doesn't need as much power to hold the latch in the retracted position. The operations narrative: doors normally closed, latched, and secured. Valid credential at card reader on secure side or wall switch on non-secure side of door. Electrically retracts the latches, and the latch bolt monitor signals operators to open the doors automatically. Free egress at all times. Key override outside in case of power outage for entry. And from this operations narrative, they can go ahead and figure out the wiring diagram that is required to make this happen. All good questions so far. Do we have any other questions on this opening? And we do have two parts. This part, the continued. Okay. The final one for today is another pair of doors in a corridor. The next pair of doors is this double egress pair of doors that is located right next to the behavioral health section of the first floor of this hospital. You see card access in and card access out. Card access locking the door from the egress side. This pair of doors also has card access on both sides. This is what they call a man trap. When this door is open, this door is not allowed to be opened. The locks are disabled momentarily, and same thing vice versa. If this door is unlocked and open, then this door cannot be unlocked. That way, if a patient is on this side and they time it just right, they're not able to bolt out this door and then out this door. This door will remain locked if either one of these leaves is open. And that helps protect the patients as well as the staff. This is right on a break line. If we go to the next plan, we can see that there's seclusion holding, a day room, the psych evaluation and psych exam. So this whole section is being separated from the rest of the building with those two pairs of doors in an interlock. And so I know when I see this, I'm going to have to use controlled egress for this pair of doors. Hopefully you recall what controlled egress is from the code session part 2. Controlled egress is physically locking the door on the egress side. A double egress door, by its name, because it's in a corridor, there's traffic in both directions. And in order to access the exit, I go through this way if I'm going to the exit this direction. If I'm coming from this direction, this is the door swings in the direction of egress when you have 50 or more people. So double egress doors, both leaves are used for egress. And in most occupancies, you are not permitted to lock these doors. But this is a hospital, and I2 occupancies do allow controlled egress where the clinical needs of the patients require their detention or restraint. So card access on both sides, typically when you see that, that should raise a red flag. You're gonna have to look up the special locking arrangement for your state. Everything varies whether you're using the International Building Code or NFPA 101 means of egress. You may have multiple codes in play. Hospitals often will have 2 or 3 different codes. This particular project, we had 4 different codes that we had to fall under. And I made an Excel spreadsheet with the requirements so that if there were any differences between the code versions, the more restrictive requirement is what applies. How can you lock these doors? These doors will have an exit device. These doors will have an exit device in this direction and in this direction. What do you use to lock the door? Take a look at the hardware set. Really the only way would be with a Maglock. And very rarely would you be able to use any kind of mechanical lock. There are some rare instances where you can. Take a look at the hardware set, then we'll look at the video, but this is a pair of 7'4" by 7 foot high wood doors, hollow metal frames, continuous hinges. Here's the video. You notice there's no motion sensor. The only thing that's letting me go through that door is that I use the valid credential. Maglock on the other side. You could have controlled egress from one direction only. This happens to be both directions, but you will sometimes see controlled egress from one direction only. On a double egress door, the astragal, the overlapping, this isn't an overlapping astragal, it's a brush astragal. But even if this were an overlapping astragal, because the doors swing in opposite direction, you wouldn't have any issue. There wouldn't be any deterrent with the overlapping astragal to inhibit the free use of either leaf. You still can use either leaf. You see the big through bolts here. Hang the door using the same Mortar hinge, the continuous pin and barrel hinge, stainless steel for cleanliness. It wraps around the edge of that wood door and helps protect the edge of that door. These doors are wide and heavy and high frequency. So for all of those reasons, the continuous hinge works best. The exit devices, surface vertical rod, less bottom rod. This particular pair is NonFire rated. We have no trim, exit only, which is very common on double egress. We don't want to have trim here. It would serve no purpose. The heavy duty flush end cap, the M110, and the M54 is the through bolts. M55 less bottom rod. The Maglock thing this is a surface mounted Maglock. The doors are 7 foot tall. You do want to be aware on Maglocks, the clearance required in a means of egress, you cannot encroach below 78 inches. And a Maglock that's surface mounted on a 7 foot door is within that range. You're fine. You still have your clearance required. But on a 6'8" tall door, this Maglock would not work because it would project down and hang down into the opening too low, below that 78 inches. And by doing so, people, if there is a fire and it's filled with thick black smoke and you can't see, you could bang your head on that. And in that case, then you would try to use a concealed shear maglock instead. Surface closer, parallel arm mounted. The spec set calls for whichever one as required. When you detail it, you would detail it as parallel arm. Kick plates on each leaf, 10-inch by 2-inch LDW. And on pairs of doors, it's really 1-inch LDW. I typically wouldn't change the spec set on a project this large to have to create a whole new line item. Probably should have been 10-inch by 1-inch LDW, but most people know that on pairs of doors, you make the kick plates a little bit wider because there is no stop. Sealing the door, the astragal, you put a brush astragal on each leaf. It does not inhibit the free use of either leaf because of the brush, and the same S88 Pemco compression seal that we've been using. Code-wise, here's our operations narrative. Valid credential at card reader, either side unlocks Maglock for entry and exit. Maglocks are fail-safe, but are tied to the emergency generator, so they won't unlock on loss of power. That itself is an exception if it's behavioral health. If it's behavioral health or infant protection, depending on your version of the IBC, there is an exception that says that the locks do not have to drop on loss of power and can be tied to the emergency generator system. That's only in behavioral health or infant protection, and only for IBC 2015 or later. If you're an earlier version of IBC, then you would have to make sure to get written permission from the AHJ for this. And this is why we write this operations narrative, is so the AHJ can review it. The plans reviewers will take a look at this. They're gonna look at the hardware schedule. They'll look at the plans and your egress paths and make sure that everything complies. And if the more detailed for something like this that you can be, the better off that you are. Maglocks to comply with IBC controlled egress for I2 occupancy. Right there, you're telling the AHJ which special locking arrangement you're complying with. It also tells the contractor, it also tells the electrician, and it tells the building owner. So everybody is clear and on the same page and knows exactly why we don't have motion sensors, why we don't have push buttons on the wall and things like that. The locks are capable of release from signal at nurse's station. So there's one extra layer of safety. The nurse's station can unlock those doors. Locks are not tied to the fire or sprinkler system for release. These doors are staff controlled for the clinical needs of the behavioral health patient's restraint. That is phrased and put that way because that is exactly how the exception reads in the IBC. Interlock pair of doors C1, C01, so that if either leaf of one of the pairs is unlocked, the other locks are disabled momentarily until the first doors are relocked. That's what I was talking about at the beginning. So if you've got two pairs, one door is open on either pair, the other pair, it shunts the card reader on the other pair. It won't let the other door unlock until that door is closed and locked. And that way a patient can't just bolt. If they time it right and they're waiting for somebody to open the door, these guys have nothing but time, and they try to think about ways that they can do things like this, and they observe everything. And for the safety of those patients, we've got to keep them in that area, and that's what the interlock does. Here's the hardware set one more time. Any questions on this? I know this is a very complicated opening because of all of the code requirements, but when you get openings like this, and you've got to take each one and look at it individually. Look at your path of egress and make sure that you're complying with the code, whatever your local code is. And there's pockets of the country that won't allow maglocks at all. I know, for example, Fort Worth, Texas will not allow you to use a maglock anywhere in the city limits even though the code for the state of Texas that has been adopted is the IBC 2012, they will not allow maglocks in the city of Fort Worth. They've got a written amendment to the code. They won't allow them. And in a city like that, then you've got to come up with a completely different solution. You may use delayed egress on the exit devices, built into the exit devices, and have them interlocked with the other pair of doors using delayed egress. You may get written permission to go with 30-second delay instead of 15-second delay. You may even get written permission from the AHJ for a longer delay. But there are some jurisdictions that won't allow maglocks, and then you've got to come up with something to make it work. And if there aren't any questions on this, I do want to make sure that you have my email address. If you have any questions, 6 months down the road, 3 months down the road, a week down the road, and you've got a project that you're working on, if you have any code related questions or hardware application questions, feel free to reach out to me. I'll point you in the right direction and maybe even to your local DSS that can help you with it. But thank you for today. Tomorrow we will have a wrap up. We'll review a bunch of different openings that we haven't hit on in the last sessions. And we'll even have some quizzes for you to get you to test your knowledge. Thank you, everybody, and have a wonderful day.